Hi everyone. Welcome to HNM Technologies online training. Firstly, a massive congratulations for finishing a module 5. In this video, we are going to learn exception handling, which is basically teaching your Python program how to deal with unexpected situations gracefully instead of just trying with those errors. By end of this video, you will know what exception actually are, how to use try and accept blocks, how to handle multiple types of errors, the else, and finally blocks, then real world patterns you will actually use. Firstly, let me open your VS Code. Before we write any code, let's understand what an exception actually is. When Python is running your program and it's something cannot handle, like a dividing by zero or trying to open a file that doesn't exist, it raises an exception. An exception is basically Python saying, hey, something went wrong here. I don't know what to do. I'm stopping. This way, Python will tell you and accepts and raises an error. If you don't handle that exception, your program crashes. The technical term is unhandled exception. Here are some of the most common exceptions you will encounter as a Python developer. Firstly, zero division error. If you try to divide any number by zero, you will get a zero division error. Then the value error. Then you trying to pass a wrong type of value somewhere like converting a string into integer and doing any operation, mathematical operation to the strings. At that time, you will get a value error. And the next, type error. Type error also you'll get when you do an operation on the wrong data type. The file not found error, you try to open a file that doesn't exist. And the index error, if you try to access a list index doesn't exist, which is the item is not in that particular index number. When you try to fetch that index number, you will get an index error. And the key error, you try to access a dictionary key and that doesn't exist. Okay. In the name error, you used to variable that was never defined. And the attribute error, you call in a method that doesn't exist in a object. We'll see how to handle the one thing here. These are not bugs in our logic. These are runtime errors, things that happen while the program is running based on data or stimulations you didn't anticipate. Let's see what an unhandled exception look like. I have a num1 and I'm assigning a 10. Also num2, and for num2 I'm assigning 0. Alright. Now I'm trying to print a result. A result is num divided by num2. See, this will crash when I run this. I'm trying to print and I'm also printing program continuous. Let's see what happens if I run this. See the red side. Trace back the most recent call, last line 25 in a module. Zero division error, division by zero. Okay, you can see the error, zero division. So notice the last two print statements never ran. The program died right at the line where it is line 25. Why? Because we get this error? Because zero division, we are dividing 10 by 0. Okay, that's why you got a error like this. And now imagine this is a payment system in a movie ticket booking app. A user enters no seat at 0 seats. Okay, your program crashes. That's a disaster, right? Exception handling is how we prevent this actually. The try except block. The most basic form of exception handling is try except block. Here is a mental model. Try to do this if something goes wrong. Except handle like this. We'll see the syntax. Try code that might cause an error. Except what I'm telling. Except do if an error happens. This is a basic syntax for try and except blocks. If any type of an error cause, it is well telling. If this error is happens, then try is one. Let's fix our previous code that we wrote. We took num1 is a 10 and then num2 is a 0. Now it's try. Result is num1 divided by num2. In except block, I'm printing. Oops, something went wrong. Cannot divide by 0. At the end, I'm also printing. Program is still running. Now, let's notice. This time we are not getting any error. We just get in a pop-up like, oops, something went wrong. Cannot divide by 0. And the end, program is still running. See, now instead of crashing it, it prints the message and it continues. That except block with no specific exception type catches any error, but this is actually a bad practice. You should always specify which exception you are catching. And result, I just send 10 divided by 0, and then here an except block, I am telling expect a 0 division error. Then I'm printing error you cannot divide by 0. Why is this specifically important? Because if you just write except, you will catch every error even once you didn't expect. That can hide real bugs in your code. Let me show you a real world example. Imagine a movie booking system. Here I'm printing just our headline, which is Spirit movie ticket booking. This is my header, and I'm here try number of tickets. How many tickets do you want? I'm asking to user. Then price per ticket around 250. Okay, 250. I'm calculating a total price per ticket multiplied by number of ticket. Cost per person. Here I'm just demonstrating a division, and then I'm printing my formatted output, which is like a total cost in rupees that we calculate total. For this, I'm expect a value error. If it is a value error, then I'm telling print invalid input. Please enter a valid number, not in the form of text. Okay. I am also expecting another error, which is expecting a 0 division. Now in this time I'm printing you need at least one ticket to do this. Then I'm printing at the end. Thank you for visiting. See here output. Spirit movie ticket booking. How many tickets do you want? Request a standard input to be if I run this to get a input from user. So I'm here printing 3. I usually get a total cost 750, and thank you for visiting, right? And again I'm trying to print here, run this, and same way, how many tickets do you want? It's asking. Now I'm telling you only one in the form of text. I'm telling, say, without crashing invalid input, please enter a valid number, not text. Thank you for visiting, right? Okay. Again we'll try. How many tickets do you want? I don't want any tickets, so I just enter a 0. Now it's the output. You need at least one ticket. Thank you for visiting again. This way we can communicate with users when error rises from inside. So here, first I'm trying to get 3 tickets. Now the total cost is 750, and thank you for visiting. And the second time I just gave only one, which is in a text format, and simply say invalid input. Please enter a valid number, not a text. And then again I tried a number which is 0. Then this time you need at least one ticket. Okay. Notice that each expect blocker catches a specific type of error, which is clean and professional. We can also catch multiple exceptions together. Multiple exceptions one line. I'll see how to do this. Try a value and this input. I'm just telling user enter a number, and the result is 100 divided by the value, which is whatever the value entered by the user. Now get a result, and I'm printing that result. I'm handling this with a expecting value error or a 0 division error. Then I'm printing invalid input. Enter a non-zero number. See, I'm trying to run this. It is asking enter a number. I'm entering a 3. I entered it in 3 and the result is 33.3336. Okay. So again I'm running. This time I'm giving a 0. Enter a non-zero number. Okay. It is an invalid input. Enter a non-zero number. Here you can see. If I enter a 0. And again I run this. And this time I have text format 1. So I'm also will get an invalid input. Enter a non-zero number. This way we can give one output for multiple errors like this. Now here is something many beginners don't know. You can add an else block to try and accept. The else block runs only if the try block had no exceptions. Think of it as if everything went fine, then also do this. Let's try this. For this I am printing heading. Before we take spirit, now we take toxic. Okay. Yeah, right. Instead of just toxic, I'm printing a toxic movie revenue calculator. Right. Now let's try. In a try collections data type float, I'm taking input enter box office collection. In bracket I'm telling in cross. I'm also telling screens and the number of to calculate collections. We want to know how many screens they released. All the information we needed. Now the average per screen is like the collections divided by accepting value error. For value error, I am printing invalid input. Please enter number soon only if it is a value error. Or another accept 0 division. When we'll use a 0 division, number can't be a 0. So I am printing number of screens cannot be 0. Then the both exceptions are not occurred. Then what we need to print in here? I am using the else block. Here I am printing the formatted output, which is next line /n average collection per screen. Average collection per screen is 5 rupees. I am also mentioning the how many floating values, 2 floated in crores, and also printing. What else I can print? Have a guess. Calculation success. Then at the end, I am also printing in a new line. I am printing program finish. I can see the output here. There was a toxic movie revenue calculator. This is what output look like. And if I run this, I am running this. Here you can see toxic movie calculator. Enter a box office collection in crores. I am using 45 crores. Number of screens 33. See the output here. Average collections per screen 1.36 crores. Calculation successfully and program finished. If I give exact one, see what if I give 0 and here also 0. Number of screens cannot be a 0, right? And again I'm trying to print crores 1. See, without asking a second question, it just give invalid input. Please enter a number only, because we already give invalid input. Please enter only numbers only. That's what we get here when it is a value error. Here we can observe one thing. Why we use else instead of just putting the code inside the try block? Because if you put an extra code inside the try block, you risk catching exceptions that come from that code too, not just the risky part. The else block keeps things clean. You only protect the risky line, and the success code goes in else. This is easy to understand the code and easy to readable. Now the most important block, finally. The finally block runs no matter what, whether an exception occurred or not, whether you handle it or not. Finally, always it runs. The question is, when do you use it? We use for a clean task, closing files, and disconnecting from databases, releasing resources. You always want this to run even if something crashed. Think of it like the end credits of a movie, like end titles of the movie. No matter how the movie goes, it is a super hit or a disaster or a blockbuster, no matter. But the credits always roll. The end cards and the title cards always in a movie. In the same way, finally block runs like this. Whether it is we have a error or not, it run. Let's try to understand in a deeper way. Okay. Firstly, I'm printing the heading. We're just database connection simulation. Then I'm in a try block. I'm printing connecting to database. Here, I'm simulating an error. Data I'm taking int corrupted data, and also I'm printing here data loaded data. I'm expecting a value error. So I'm value error as I'm aliasing e. Okay. Here I'm printing error loading data is a value error. Without having that, I'm just printing a e because we aliased that. Here is another block which is a finally, and here I am printing closing loading data. Yeah, closing database connection because I need to run this always. So I'm printing it always runs. So that's why I took in a finally block, and also printing cleanup done at the end of a program. Here an exception is raised even though the error loading invalid literal for int with a base 10 a corrupted data. This is the exception that was raised even though, and the final block was here you can see final block closing database connection and cleanup done and end of the program. This is what a final block always do. The final block still runs and close the connection even though an exception was raised. Here are some practice questions. The level wise beginner, intermediate and advanced. Pause the video and look at the practice questions. The first one is write a program what asks the user to enter their age. If they type text instead of a number, catch the value error and print please enter a valid age. Like that will I need to print. And then the second one is the intermediate level. I create a simple calculator that takes a two number and an operator which is a plus, minus or a multiplication division from the user. Handle the zero division error and then at the same time when dividing the value error, when dividing and the value error for invalid inputs, use else to show the result only on a success. Okay. Then the advanced level, simulate a movie ticket booking system for a Tollywood film. Ask for the movie name from the user end and then a number of tickets and seat type, whether it's gold, silver, platinum, or then handle value error for non-numeric tickets, whether it is a text format. A custom check if ticket requested is more than a 10. Raise a value error with a custom message and then use finally to always print a book reference number. Here are three questions and three different levels. Open your VS Code, then try these questions. A quick wrap up. That's what we done in this video. We learn what exceptions are and why they happen, and also we know how to use a try except to catch errors, and then catching a specific exceptions versus a generic, and we know using a as to get a error message, then the else block that runs only on a success, then the finally block which is always runs for cleanup whether it is error or not. By at the end it always runs. Always remember in a try we are giving in a try that the what the code that might be fall or that might be give a error, that exact code we are giving in a try, and then handle is a answer for that answer for the try and specifying the what type of error it is. For that we're giving a print statement for that, right? Then in else it only runs when there is no error in our code, whether it try and accept. Then finally is always runs. It's like a end line. You may have a doubt why you use a finally. At the end we'll just print without finally, but it won't work in the function, right? Finally it works inside the program. So finally the purpose is to shut down the system at the end. Without using the finally, we just give a print shutdown. It just prints the statement. It won't do the work actually. So that's why we will always use the finally. That's it. That's it about this video, exception handling.